Hello, in this recording I would like to do something a little bit crazy. We're going to look at an equation. We're going to solve the equation, but what we're going to focus on is identifying the properties of real numbers that we use in this process. And I'm hoping that in the context of solving an equation, the properties of real numbers will make a little bit more sense, like, when am I ever going to use this? And so my goal is to show you that, you use it all the time when you're solving equations, but this isn't really about solving an equation. I'm not going to solve the equation the most efficient way, or the way that you would normally solve an equation, because what I'm really trying to do is to illustrate the properties of real numbers and try to squeeze in as many of them as we can. And the idea is that we use them all the time, and we use them without thinking about them, and we use them kind of almost like we use them without even saying we're using them, like without even showing it. We just assume them all the time. So let's get down to this. Here's the equation. 1/2 times the quantity x plus 2 equals 3x plus 6 minus x. Okay, so what's the first step we're going to do? Well, the first step we're going to do, and you can see it illustrated here, is we're going to use the distributive property on the left-hand side. So we're going to take that 1/2, we're going to distribute it in, so 1/2 times the x and 1/2 times the 2. That is the distributive property. And remember, the distributive property has multiplication and addition in it. It's like distributing multiplication over addition. So it's not specific to either addition or multiplication, which some of the other properties are. Okay, now on the left side, I went ahead and, just because I didn't want to be insanely crazy, I made a change. Can you see what the change is on the, I said left side, I meant right side. Can you see what the change is on the right side? And this is the first thing that I want us to really look at, is that when you're looking at these really proofs, you want to look and see what has changed. So I have that 3x there, that didn't change. I have this plus 6 here, ooh, that changed. It got moved over there. And then that minus x, it got moved over here. So what happened, I swapped the plus 6 and the minus x. And that is the commutative property. Commutative property. And commutative property, what kind of commutative property? Well, what we're doing here in this sentence is we're adding these terms together. Now you might say, well, that minus 6, that's a subtraction problem, but for our purposes, and when we look at these properties, we're not going to have a separate property of addition and subtraction. We're just going to say everything is addition. And that gets to the definition of subtraction, which we'll get to. It's the same as adding a negative. But this is the commutative property of addition. Okay, now let's go from the second line to the third line. What happened here? So again, we have 1/2 x, and that stays 1/2 x. And we have 1/2 times 2, and that changed, that turned into 1. So 1/2 times 2 was replaced with 1. And you can always say the substitution property, because that's what we did. We substituted something for what it equals. But that's not what we're using. This is the property of reciprocals. So I'm going to write the word reciprocals here, but it's the property of reciprocals. Reciprocals. A math teacher, not a English teacher. And this is the property of reciprocals. Sometimes it's called the multiplicative inverse. So you multiply the multiplicative inverses together and you get 1. All right, now on the right-hand side, we'll get it right this time, we have 3x, still there. We have negative x. And now instead of negative x, I rewrote that as negative 1 times x. And then the plus 6 is the same. So the only change was I took out the negative x and I put in its place a negative 1 times x. And this is an interesting property. We can do this sometimes, and sometimes we go backwards. So we say this is the identity property, But instead of starting with something times 1, let's see, let me spell it here, identity, property of multiplication. Instead of starting with 1 times x and then rewriting that as just x, I did it the other way around. I started with x and then I changed it to 1 times x because, well, we'll see in the next step why I did that, but that's the identity property either way you go. So whichever one you start with, you end up with the other side of that identity. That's the identity property. Okay. And it's multiplication. When you multiply 1 times something, you get that thing. All right. Let's go to the next line. 1/2 x is still there. Plus 1 is still there. Notice that the left side is pretty much simplified as far as we can get. We can't add 1/2 x to 1. We can't simplify those either one of those any further. So we're gonna stop, take our eyes off the left side for a while, and just focus on the right side. Okay. So on the right side, notice that plus 6 is still there at the end, but this 3x and the minus 1x has been changed into x times the quantity 3 minus 1. And so what did I do? Well, I took that 3x and the minus 1x, and I said, hey, look, they both have an x. Let's take those x's out, and that's the reverse of the distributive property. We saw the distributive property in our first line. We saw the distributive property working kind of in the order that we expect it to happen in the first line. Well, now we're doing it in reverse, where I sometimes say we undistributed the x. We took the x out and left just the 3 minus 1. And so what we're saying is we're going to multiply x times those numbers, but after we do the subtraction. We're going to do the subtraction first. So the distributive property works both ways. This, by the way, is just a little kind of little proof of combining like terms. We're allowed to combine like terms, and in fact, you may have been thinking to yourself, wait a second, why don't I just combine like terms? Because I can. I know that 3x minus 1x is 2x, and I don't need to make a big deal about it. And you're right, most of the time we don't make a big deal about it. But the distributive property and the kind of the reversal of the distributive property is why we're able to do combining like terms. Okay, I'm going to scroll up here. Let's see if I can get this to work. And there we go. And let's go to the next few lines. Okay, so the left side is still the same, but the right side has been changed. I took that 3 minus 1 and I changed it into a 2, and then I multiplied that times the x. Okay, so just doing the order of operations there, the 6 stayed the same. Now, what's the property here? This one's a little bit awkward because there's not really any property. I mean, technically we could say the commutative property. I did the commutative property because, and let's see, commutative property of multiplication, because what did I do? I took 3 minus 1 is 2, and so I had x times 2, and then I swapped it around and wrote 2 times x. So if you wanted to, we could call that the commutative property. I'm going to suggest maybe that we could call this the closure property. So we had 3 minus 2, and 3 minus 2 is a number, right? 3 minus 2 equals something, some real number, 2. I'm sorry, I've been saying that wrong. I apologize. I'm seeing all those 2's and I keep saying 2. It's 3 minus 1, so 3 minus 1 is 2, so I replace the 3 minus 1 with a 2. The closure property says that, you know, when you add or subtract two real numbers, you get, there's one unique answer to that. So, and this having 2 different steps in one is an illustration of one of the reasons why this is so crazy. Like, we never do this because we tend to skip steps all the time. We would have skipped most of these steps if we were doing this problem and our goal was to do solving the equation. So these properties get combined all the time, and it's actually really cumbersome and really laborious to kind of unscramble them and to do them one at a time. So, but we'll keep slogging forward. Okay, so now we have We're finally going to do something to the left side. We have 1 half x plus 1 half x plus 1 and 2x plus 6. And this is the point where we have everything's simplified on the left side and everything's simplified on the right side. And so we have to start looking about getting things swapped over from one side to the other so we can combine all the x's on one side and all the not x's on the other side. Okay, so how are we going to do that? Well, we have 1 half x, and then we have the 1, and then we added in something that wasn't there before, this negative 1 half x. And then on the other side, we have 2x, and then we have plus 6, and then we also, again, added in this negative 1 half x. And that is, say it with me all together here, the addition property. The addition property of equality. That says that you can add the same thing to both sides of an equation, and the equation is still equal, still true. Okay, so we added 1 half x to both sides, and why did we do that? Well, next step, 1 half x plus negative 1 half x, or 1 half x minus 1 half x, is 0, and that was really what we did that for. Didn't change the plus 1, and that was the, let's see, the property of opposites. Property of opposites. The property of opposites says that if you take a number and add the opposite, or the negative version of that number, you get 0. And so 1 half x plus negative 1 half x is 0. On the left side, this one's a little bit more tricky. Now notice what we did is we combined 2x and negative 1 half x, and we put them together and got 3 halves x. Now, what property is that? Well, we can say the closure property if we want to. Notice that the last time we were in this situation, combining like terms, we broke it up into like 3 steps where we had to first undistribute the x, and then we had to combine the two numbers, the coefficients together, and then multiply them back together and change the order. So like there's a whole long list of properties we've already gone over. I'm not going to do that again, so let's just say closure property maybe. All right, so next step. On the left side we had 0 plus 1, and we rewrote that as just 1. And what is that? That's a property that is, for those of you following along in the textbook, that is a property that is associated with addition, and that's the addition property of the addition property. Oh no, that's the identity property. Oh my goodness, can't believe I didn't say that right. Oh, I apologize. That's the identity property. We got the identity property of multiplication, which is when you multiply by 1. This is the identity property of addition when you add 0. Doesn't change the identity. Okay, oops, and that's supposed to be down here. Okay, and on the right hand side we didn't do any changes, so let's scroll down, whoops, one step further. What changed here? Well, we had a 1, and now we have a 1 minus 6. We had 3 halves x plus 6, and now we have 3 halves x plus 6 minus 6. So we added a minus 6 to both sides, which is the addition property of equality. Okay, and why did we do that? So we could combine 6 minus 6, which is the inverse property, or the property of opposites. Okay, and you can see how these get used all the time. Maybe we'll call this the closure property, because we combine negative 1 minus 6 is negative 5. and then we're going to add 0, and that's the identity of addition, identity property of addition. Okay, now let me just say, because this is getting kind of tedious, that aren't you glad we don't really do this every time we solve an equation? We're doing it today only, really. But it's so important because when we get deep in the weeds of algebra and doing algebra with really complex kinds of things, right? Right now it's not that difficult. There's some fractions in there, but it's not that difficult. We just have one variable. We can do math with much more complicated stuff. It's really good to be able to understand the fundamental rules that we are following and know that we're following them correctly and know what we can and cannot do even when the situation gets really hairy. Okay, so what changed here? We have -5 and we have 3/2 times x, and in both cases we added this new thing, not adding, we multiplied this new thing, which is times 2/3, so that's the multiplication property of equality. So the multiplication property of equality. Multiplication property of equality. I'm trying to demonstrate some ways that you can maybe shorten your writing here. I think it's okay to shorten some of these, but be careful because a lot of these rules have kind of similar looking names, so you have to be clear enough that we can tell which rule it is. Right? Like you couldn't just say the multiplication property because there's lots of different ones that have multiplication in them. Okay, so we've got our closure again. Oops, I said spelled it wrong. Closure. And then here, what did we change? We have 2/3 times the quantity of 3/2 x, and now we have 2/3 the quantity 2/3 times 3/2 the quantity times x. So we just changed the parentheses, and this is a great example of one that is hard to spot, but we use it all the time. That is the associative property. And notice the situation. We were multiplying three things together there, and what we said is, doesn't matter which of the three things we multiply together first. And in fact, we chose to do 2/3 times 3/2. Why? Because those are reciprocals. So this is the reciprocal or the multiplicative inverse. Reciprocal property or multiplicative inverse property. Reciprocals multiplied together to be 1. And now we're going to do the identity property. 1 times x is x. That's the identity property of multiplication, not addition. And finally, we have -10/3 equals x. And then I swapped it around and I said x equals -10/3. What is that? That is the symmetric property. And when you saw the symmetric property, you thought to yourself, I'll never use this. But it's the one, it's symmetric property of equality. It's the one that lets you change around an equation, swap sides of an equation. And so even though it's mind-numbingly obvious, as so many of these are, it comes in handy. And so it's important to state that we are following a rule here. All right, well, that was crazy. I'm not going to ask you to do anything nearly as crazy as this, but this gives you a really big example of applying the properties in a real life equation situation. Thanks for watching.